Today I will be I'm here to talk to you about a potential shopping mall or industrial park near the intersection of Highway 77 and Warlick Road. Before I can make a recommendation on whether or not this area is suitable for building, there are a few things you need to understand. The first are the types of soil in this area. If you look at the map currently up on the screen, we can see that there's three different soil types in the area of interest. The first is the Wymore Silty Clay Loam. The Wymore Silty Clay Loam is comprised roughly 60 to 75% silt, 0 to 20% sand, and 36 to 40% clay. The two other types are the Kennebec Silt Loam and the Judson Silt Loam, which is down here. And those are both roughly 73 to 87% silt, 20 to 50% sand, and 0 to 25% clay. Now, we know the makeup of these soils, but how did they get here? Why are these soils the way they are in this area, and why is there different soils everywhere on the planet Earth? Well, there are several different soil forming factors that come into play when you're talking about different soil types. The first is parent material. A few soils weather directly from the underlying rock. These residual soils have the same general chemistry as the original rocks that they came from. More commonly, soils form in materials that have moved in from elsewhere. Materials may have moved many miles or only a few yards to get where they are today. Wind-blown lows are common in the Midwest. They bury glacial till in many areas. Glacial till is a material ground up and moved by a glacier. The material in which soils form is called the parent material. In the lower part of the soils, these materials may be relatively unchanged from when they were deposited by moving water, ice, or wind. Sediments along rivers have different textures depending on whether the stream moves quickly or slowly. Fast-moving water tends to leave gravel, rocks, and sand, whereas slow-moving streams or lakes tend to leave a finely textured material such as clay or silt when the sediments in the water settle out. Another factor that comes into play when we're talking about soil types is the climate. Soils vary depending on where you are in the world. The soils we have here aren't going to be the same ones that are down by the equator. Temperature and moisture amounts cause different patterns of weathering and leaching. Wind redistributes sand and other particles, especially in deserty regions. The amount, intensity, timing, and kind of precipitation influence soil formation. Seasonal and daily changes in temperature affect moisture, biological activity, rates of chemical reactions, and the different kinds of vegetation that are in an area. The third forming factor is the topography of the area. So slope and aspect affect the moisture and temperature of the soil. Steep slopes facing the sun tend to be warmer, just like say, a south-facing side of a house. Steep soils may be eroded and lose their topsoil as they form, so they may be thinner than the more level soils that receive deposits from areas upslope. Deeper and darker colored soils may be expected on the bottomland. The fourth forming factor is biological factors. Plants, animals, organisms, and humans affect soil formation. Animals and microorganisms mix soils and form burrows and pores. Plant roots open channels in the soils. Different types of roots have different effects on soils. Grass roots are fibrous near the soil surface and easily decompose, adding organic matter. Tap roots open pathways through dense layers. And microorganisms can affect chemical reactions between the roots and the soil. Obviously, humans have a huge impact on soil depending on if we're building things in the area, how much foot traffic or car traffic's in the area. The vehicles we drive obviously produce waste that goes into the atmosphere but also can settle into soils. So any biological life has an effect on the soil. And the last forming factor is time. So obviously over time, soil change. The soil formation process is continuous. It's not something that's just, oh, here's the sediment. It's just going to settle and stay the same forever. So all the previous factors that I listed aren't just a stationary thing. They're continuous and always changing, and thus soil changes over time as those formation factors change. So as far as can the forming factors in our area of interest, the parent materials in this area are for the Weimar silty clay loam, which would be up here in the area I'm circling with the cursor. Those are formed by lows, and remember, lows were the wind-blown sediments or sediments brought in by glaciers. In the Kennebec silt loam, the parent material is alluvium, and what alluvium is it's basically just materials left in an area by flowing streams. And for the Judson silt loam, which is down here in the 7050 range, those are fine salty colluvium. And what colluvium is it's basically sediments deposited by a rain wash, sleet wash, or sediments that are deposited by a downward creep. So what a downward creep is if there's a soil on the side of a hill, the stuff is gradually going to go down the side of the hill in a downward motion. So now that we've talked about the different types of soils, the forming factors of those soils, and the parent materials of the soil in our area, we can go ahead and look at some of the suitability and limitations of this area would have on building. So first we're going to look at small commercial buildings, because that's what you guys would be interested in. The first factor we're going to look at is the corrosion of concrete in the area. So this map right here shows us basically how the soil in the area could negatively impact concrete if the concrete wasn't specially made for that type of soil to avoid corrosion. So if we look in our area, the 7231 and the 7050 down here are green, meaning that the soil in this area is probably not going to have any negative impact on concrete corrosion. If we look up here in the 7684 area, this soil could have a low to moderate impact on concrete. So if you were to build in that area, you'd want to take special care to ensure that the concrete would not be negatively impacted. This map right here looks ominous, but this basically, like the last map, shows the corrosion of a material, and then material on this map right here is steel. So if we look again in the 7231 and 7050 soil types right here, there's a moderate risk of untreated steel, uncoated steel, of having corrosion effects from the soil. If there's steel touching the soil, over time it could corrode. And if we look up here in the 7684 area, which would be in the top part of our area of interest, this soil could have great negative impacts on steel touching the soil. So special care would have to be taken in all of these areas to ensure that the steel is coated in a way that the soil would not negatively impact it. So my overall recommendation for a small commercial building in this area, due to the risk of corrosion to concrete and steel, I would recommend that the building be built on top of the Judson silt loam, which would be this soil down here in the 7050 range, due to that area having the least negative potential impact on the building materials. The next thing we're going to look at is local roads and streets. So obviously, we may need to, if we're going to build a shopping mall, we're going to have some roads leading into it. There's already a couple in the area, but they're not going to be direct access to a shopping center or industrial park. The area of interest, unfortunately, is not very favorable when it comes to road construction. There are factors which could increase costs in building roads in the area. The main risk factor in this area is frost action. What frost action means is basically freezing and thawing in the area could cause cracking in the road structure. So special care would need to be taken to ensure that cracking was kept to a minimum. And the last thing I want to cover is the flooding frequency. So obviously flooding is a huge issue when you're building things. One flood could destroy lots of property. So for the majority of the area of interest, flooding isn't a huge risk. And even in that blue areas here, it's only an occasional risk. So if you were going to build in the Judson loam down here in the 7050 range, I would recommend that special like a safeguard of some sort would be taken to ensure that if a building or a complex was built there, flooding would be a potential hazard that would be taken into account when building. There was some flooding at some point, it wouldn't cause property destruction. So my overall recommendation for the area that we talked about today would, I think it's has potential to be an excellent spot to build. However, there are a couple of factors that it could increase the overall cost of the project. Extra care would be needed to ensure that steel touching the soil in the area was coated to prevent corrosion. Roads in the area would have to be specially made to ensure that freezing and thawing would not have a negative impact on them. Finally, if building on the Kennebec silt loam, a safeguard would need to be in place that if flooding occurred, it would not negatively impact the building area. So that my final verdict is go ahead and build if you're willing to shell out a little bit of extra money to ensure that proper safeguards are in place. And that wraps up my presentation on this area of interest. Thank you.